Hi! Welcome back to Gillesania Engineering Videos, your daily supply of solutions to engineering problems. Okay, today we will discuss propped cantilever beam, particularly here. Okay, let's have this problem. Determine the reactions at A and B and also the deflection at C. Deflection only. And then maybe we can find the maximum deflection later on. Alright, so let's say the modulus of elasticity is still 200 GPa and the section modulus, moment of inertia is 120 times 10 raised to 6 millimeters to the fourth power. The beam is 12 meters long span. The load is varying from 30 at the fixed end to 10 kilonewton per meter at the simple end. Alright, C is 8 meters from the fixed end. So how will we solve this one? Well, first again, for the board exam sake, ito yung common na binibigay ng examiner. So I urge you to memorize the formulas involved here. Okay? So, ito yung formulas. You can find the formulas in our website. So, meron tayo ditong, this is still under construction. Parami ito later on. So, meron dito under the study companion, we have theory of structures, and then for propped beam. So, nandito yung mga reactions sa moment. So, we have the reaction for a concentrated load at any distance, concentrated load at the middle. Uniform load is, the reaction is at B, 38 WL. And for the varying load, the reaction is WL over 10. So let's make use of these formulas to solve the reactions or the reaction at B. Alright. Okay, so let's divide the loading into two. We have the uniform load, like that, and the uniformly varying load. So this will be 10 and this will be W1. And let's call this W3. Okay, this one here. Okay, W3, W1. Where in W3 is equal to 30 minus 10. That will give you 20 kilonewton per linear meter. So that for RB, that will be the reaction due to uniform load. That will be equal to, okay, this one here, the one I have shown you a while ago. That will be 38 WL for the uniform load, and for the uniformly varying load is WL over 10. So let's use these formulas. So 38 W1 times L. L is 12, and then 110 W3 is your W3. W3 times L. Substituting the values, that will give you that one, 10. Our W1 is 10, L is 12, and then our W3 is 20. This gives us 69 kilonewtons. We have now our reaction at B. Okay? Yeah. Now, for the reaction at A, that will now be very easy. Summation of forces vertical 0. This will be the total load minus the reaction at A, giving you 171 kilonewtons. You don't have to memorize that. Even the moment, you don't have to memorize for the formula for the moment at A. Once we have the reactions RB or the reaction RB, you can easily solve for the moment at any point. So, for the moment at A, that will be RB times the, okay, this one here times the length, and then minus the moment caused by this load here and the moment caused by this varying load. That will be RB MA, positive RB times 12. Why positive? You might think, sir, bakit positive? The counterclockwise band? No, ha? If you are solving for bending moment, positive moment is the moment caused by a load that bends the beam concave up. So RB at A causes the beam to bend in this way, while the weights causes the beam to bend downward. So that will be a negative moment. So that will be 69 times 12 minus for the uniform load 10 times 12 times 12 over 2 or 6, and then minus 1/2 12 times W3 20 times 1/3 of 12. So the moment at A is 372, negative 372 kilonewton. And before we proceed for the deflection, well, by the way, these are the reactions. We have completed the reactions. Now, let's compute ahead our flexural rigidity in kilonewton meter squared. Your E is GPa, and your I is mm to the fourth. So we will use here MPa, so that's 200,000 times I. This will give you Newton millimeter squared. So let's make this kilonewton meter squared. You divide by 1,000 here and 1,000 squared. You divide this by 1,000 to the third power. 1,000 cubed. This gives you 24,000 kilonewton meter squared. That will be our EI. Okay. Now, so let's now compute the reaction or the deflection at C. There are two ways to do this. Okay? You can use area moment if you want. You can use double integration. Later on, we will apply double integration. Or you can use the formulas. If you have seen the video I gave you regarding cantilever beam, we will be using the same approach. Okay? So this is how we do it. Let's use the formula. The formulas for cantilever beam. You might say, sir, hindi naman yung cantilever beam. Prop beam yan. Prop cantilever. Alright, so how is cantilever beam applicable to this? We can do that. We can do that. So, these are the reactions. Already, I have included here the reactions. Okay? Now, this is how we do it. So, we are up here for the displacement at C. Let's cut this segment off. Okay? So, we have here our line, and then this will be W1, and I'll call this W3. W3. So let's compute your W1 is 10, your W3, we can compute that by proportion. No? We can make a straight line up to here, and this, of course, this will be 20 here. 30 minus 10, 20. So that W3 is to 4 as 20 is to 12. That's by similar triangles. No? W3 is to 4 as 20 is to 12. That gives us W3 is equal to 20 over 3 kilonewton per linear. Then what will we do is, let's separate this part here. Alright. So I'll call this W4. Of course, W4 will be W1 plus W3. So to use the cantilever beam for this, there is a fixed here. You can always use the cantilever beam whenever a fixed end is involved. So we have cut this part here. Of course, the load caused by this one will be applied here. Let's call it P prime. That one, P prime. And the moment caused by this part here will be applied at C. Let's call that M prime. Let's compute that. Now, once we compute that one, then we can compute the deflection at C using the cantilever beam formulas. Okay, so P prime. So P prime will be, let's assume downward positive, upward negative to follow the direction here. That will be 10 times 4, W1, W1 times 4, plus 1/2 W3, which is, W3 natin is, ano ba yung W3 natin kanina? Ito, 20 over 3. 1/2, 4 times 20 over 3. Okay? Minus 69. Okay? So, as you can see, we have a negative result. So, meaning, your P prime is not downward. This should be upward. Malaki yung 69 kaysa sa W3 and W1 combined. So, this will be upward. Let's change that later on. And then for the moment, assuming clockwise positive, okay, assuming clockwise positive as shown here, here we assume downward positive because this is how I assume it to be acting downward. So clockwise positive, that will be 10 W1, 10 times 4 times 2 plus 1/2 4 times W3, 20 over 3. Okay? Times the moment arm is 1/3 of 4. Okay, this is it. And then minus 69 times 4. And this gives us negative 178.222, meaning it is not clockwise. It will be counterclockwise. Okay, so nag-assume kasi ako dito ng downward, we got a negative force, so meaning reverse siya. Ito naman, clockwise, we got a negative sign, meaning reverse yan siya. Okay? Yan. Let's compute na lang muna W4. W4 is W1 plus W3. So that's 50 over 3. Okay. Now let's change the direction here because we found out that the reverse is the correct direction. Ayan. And then let's put on na lang the values. So now we have a cantilever beam loaded with uniform load, uniformly varying load, a concentrated load, and an applied moment at C. Okay, before that, we will compute first W5. W5 will be 30 minus 50 over 3. So that's 40 over 3 kilonewton per meter. So once again, we will use these formulas here. We are preparing for the board exam. In my experience, with this examiner, matagal-tagal na rin siya, mahilig siya sa cantilever. Alright, so ito yung formula for the uniformly varying load. The deflection is WL to the 4th over 30 EI. And this is the formula for the applied moment, ML squared over 2 EI. And for the uniform load, ay WL to the 4th over 3 EI. And for the concentrated load, the formula is PL cubed over 3 EI. Our L here becomes 8. Okay? It will now be 8 meters. And by the way, advertisement muna tayo. Before I proceed, I would like you, okay, those of you who are preparing for the board exam, as of recording, today is April, particularly April 13. Yes, April 13 ko ito na-record. We have launched our GRTC Lite and GRTC Plus. Yun yung bago namin. Now, what is GRTC Lite? No? Okay, yung kung nagdududa pa kayo, kung magre-review pa kayo ngayon, kasi baka dudable pa kung may board exam ngayong November, is the best program for you. GRTC Lite. So, GRTC Lite, here, if you click on this site, ito yung bagong enhancement namin. So, GRTC Lite, you can find here all the lecture videos of our entire review. And then the good thing about this is you can just select a subject and a topic. It will lead you directly to the topic. For example, if you want to study about mechanics and strength of materials, and then you study about mechanics and then two force members explained. Okay, and it will lead you to that part segment of the video. Okay, two force member. Okay, madaling gamitin yan. So if you want to study about block shear, for example, in steel design, it will lead you to that portion, block shear. Okay, kaya very easy. You are free to any subject na gusto mong pag-aralan on that day using this site namin. And the price, by the way, our GRTC Lite is only for ang GRTC Lite namin is 499 pesos per month, and our GRTC Plus is 899 pesos a month. The difference between the Plus and the Lite, okay, what's in the Lite are available din doon sa Plus. Ang nadagdag sa Plus is ito, growing library. So we have inputted lots of problems na it can be found here. Nandito, by subject din yan. Okay? And this will include the recent board exams. Okay? So you can find here GRTC Plus. Only those Plus members can access these videos. Kasali dito yung 2019 na board exam, may 2018, and this will grow yung library namin, palaki ito ng palaki. Every week, nagdadagdag kami ng mga videos. That's for the GERTC Plus. Okay? Yung ano nila, other than that, so if you're a member of GRTC Plus, you have 50% discount to any of our books. If you want to buy any of our books, kahit ilang copy, automatic ka 50% discount kapag member ka sa GRTC Plus. And of course, kung the first 100 members namin, makakakuha kayo ng 50% discount, isang book lang. Any book, 50% discount. Okay, that's for the first 100 members. Okay, so yan yung aming GRTC Plus. So, napakaganda nito kasi kung kahit na hindi lang siya nagre-review, para din sa mga undergraduate and those who are studying or nasa abroad or planning to take the board exam. Okay? Sige, tuloy natin. Mahaba yung ads. Okay. So, ituloy natin. Kinat na natin. No? So, we are now ready to compute the deflection at C. Your M prime and P prime in its proper direction is already shown here. Okay, so delta C will be equal to, first, let's have the uniform load, WL to the 4th over 8I. Okay, and since this is causing the beam to deflect upward, so that should be positive. Okay? Sorry. Sorry. Okay. So we have our delta C. So delta C is negative. This is caused by this uniform load here. So we have here a negative 50 over 3 WL to the 4th. Your L is 8. L to the 4th over 8 EI. And then for the uniformly varying load, this one, the triangular loading here. One here. So that will be WL to the 4th over 30 EI negative also. Causes a downward deflection, downward movement. And then for the concentrated load P prime, it should be plus because this will cause an upward movement. So PL cube over 3 EI. P prime, okay, I'm using kilonewton and meter here. And then for the applied moment is ML squared over 2 EI, positive also. Positive. Okay? So with these values, simplify that. That will give you negative 1976.8391 over EI. And your EI is already expressed in kilonewton meter squared. Sorry. So the unit here is already in millimeters. Na? Okay, na scramble. Baliktad natin. Anyway, 24,000 yung ating EI. So this is in meter, I mean. So this will give you 82.368 mm. That will be our delta. Okay? So now let's solve this using the area moment. Not area moment. Double integration. Well, of course, this formula here, if you know the formulas for deflection of cantilever beam, apply mo yan basta may fixed end. Gawin mo lang ito. But if you want naman talaga, the best solution talaga is the double integration. Okay? Let's try double integration for this. Well, of course, we will assume na that we already have the reactions. Okay? We have our double integration method. We already have the reaction at B. We don't need the reactions at A here. Okay. Now, you have two ways to do this. Now, of course, this is our elastic curve. And then, yan. Now, pwede pong, okay, dalawa yung option mo dito regarding your reference point. Pwede kang mag-origin dito sa A. Pwede kang magsimula sa A so that this will be your y-axis and your x-axis like this. So, meaning, you solve the moments looking to the right at to the left side. But if you do that, it will be a disaster because you will have a hard time doing this triangle here. Mahihirapan ka. Okay? Well, you can do that. Pero the best option here is to take reference at B. Let's take reference here. Ayan. Our positive x is going to the left. No problem. Going to the left is positive. Y naman natin is vertical. Going up is positive. So that at any distance from B, say x, alright, ito yung kanyang deviation. Okay. Ang problema lang dito, in my experience sa review, most students does not know how to make the moment equation. Well, kasi if you can do the moment equation easily, napakaganda ng double integration talaga. Kaya lang, most students kasi gusto nila formula. Kaya yung pinakita ko kanina na solution, formula-based, well, that would be okay sa mga students na okay lang sa kanila mag-memorize ng formula. May talent silang mag-memorize. Pero ito yung mga principle-oriented, maganda to. Alright, then yung moment. This is the challenge. Kukumpitin natin yung moment. So, let's divide this into two areas. Rectangle and the triangle. Okay, of course, for this rectangular part here, this will be W1. And let's call this W3, Wx. So, let's solve Wx in terms of x. Yun ang gagawin natin. Express natin, no? Of course, this one here is 20. So, by proportion, Wx is to x as 20 is to 12. So that your W in terms of x is 5/3 of x. Okay. Then, ito na yung ating pinaka-highlight. Yung ating moment equation. We know the double integration equation is EI y double prime equals the moment. And by the way, our EI is constant all throughout. So, no problem. EI y double prime equals mx. And what's the moment here? To the left. It will be caused by three loads. We have the RB, we have this uniform load here, and we have this triangular load here. So for the RB, that is clockwise. I mean, not clockwise, but positive moment yan. RB times x, 69 times x. And then for the uniform load, it will be 10 times x over 2. And for this bearing load will be 1/2 x by Wx, which is 5/3 of x, times x over 3. Simplifying this, you have that. Okay. Actually, this is the only part that is complicated. If you know how to get this, this is the easiest, the most convenient and powerful way in computing deflection of a straight beam. Okay. Okay. Dito tayo. And of course, before we do that, we expect here two arbitrary constants or constants of integration C1 and C2. Okay, we need boundary conditions. So we know that here, this is our origin, huh? When x is 0 at the origin, y is 0. Another is when x is here, which is this. Take note, this is our origin. When x is positive 12, positive going to the left, I will do it positive going to the left, not negative. Okay, when x is equal to positive 12, y is 0. And another, this is a fixed end. The slope at A is 0. So meaning when x is equal to 12, y prime or the slope is 0. We can make use of that para madaling makuha yung constant of integration. So we have this equation now. So we have EI y prime. So integrate natin. So the integral of this is x squared over 2. This is x cubed over 3. This is x to the 4th over 4. Okay? So I hope you can follow this. Ayan. So ginawa ko na lang 4 times 18 is 72 plus the constant of integration. Constant of it. Now, can we solve now the C1 at this point? Yes, we can, because we know a point in the beam where y prime is 0, and that is at A. Meaning when x is equal to L, which is 12, your y prime is 0. So knowing that 0, this is 0, x is 12, you can solve for the value of C. Just check on its value, it will be negative 648. So therefore, we already have the equation for the slope. This is now the equation for the slope. And finally, for the deflection, integrate that again. The integral of x squared is x cubed over 3. This is x to the 4th over 4. X to the 5th over 5. And it will be 648x. And it will be like this. Notice, I just cancel out the 5 kasi 5 over 5 naman siya. So naman becomes 12 because 4 times 3, 3 times 4, 12 times 3. Okay, we have here another constant of integration. And we can solve that because here, when x is 0 at b, when x is 0, y is 0. And with that, 0, 0, 0, 0, 0 din yan, your C2 is equal to 0. Finally, this is now the elastic curve equation. Very simple. Now, we have the elastic curve. So, alam niyo na what we can do with these equations. For any value of x, we can easily get the slope and the deflection. Ito yung pinakamadali. Ang problema nga lang talaga, if you will just practice, no, this one here, then yeah. Again, if you don't like this one, you can always use the formula I presented in the previous discussion natin. Alright, so finally now, okay, bitin natin lahat. So, we are after for the reflection at C. Point C is 8 meters galing ng A, or that will be 4 meters from B. 4 meters from B. So, at C, X is equal to 4 meters. Just substitute that in here. Then we can get the deflection, YC. Okay, just check the value. It will have the same value as Cantilever. The negative sign denotes that it's below our origin. Our origin is at B, along the beam. Alright, now ang gagandahan ng double integration is in computing the maximum deflection. Because here in this type of beam, the maximum deflection is here and the slope is 0. Take note, not all If it is a cantilever beam, it's at 0. The maximum deflection has hindi 0 yung slope. So that way, let's call it point D. Maximum deflection point D. So, hanapin natin yung D. So meaning, at this point, at the lowest point, the slope of the elastic curve is 0. Y prime is 0. Then using this formula here, or this equation, equating this to 0, okay, you can solve for the value of x. You can just use your calculator, shift solve, and just put the value here. That will give you 5.201. Alright, and with x already known, you can substitute that in here to get the deflection at D. Already the maximum deflection. And that will give us negative 87.9. Okay? Yeah. So, I hope you learned a lot from this video. Again, I'm inviting you, if you are planning to take your board exam this coming November, or mag-prepare kayo, and we are not certain kung matutuloy or makakancel na naman yung exam, that we do not know because of our COVID cases. As of recording, April ngayon, 13, parami pa yung cases natin. Let's pray na matapos na to. Okay? So, GRTC Lite or GRTC Plus, the best for you. Okay? So, thank you so much for watching.